Question 1. Under the assumption that Mr. Thompson is auditing a commercial rooftop unit, he notices that the condenser coil is covered with a thin layer of dirt and debris. The unit has been showing slightly higher discharge pressures than design. What should Mr. Thompson prioritize to improve system efficiency? A. Replace the compressor immediately. B. Clean the condenser coil and verify airflow across the coil. C. Adjust the expansion device setting to compensate for higher pressures. D. Increase refrigerant charge beyond manufacturer specifications. Answer. Correct answer. B. Explanation. Cleaning the condenser coil is critical because dirt and debris impede heat transfer, causing elevated discharge pressures, higher energy consumption, and potential system stress. Replacing the compressor without addressing the root cause is unnecessary and costly. Adjusting the expansion device or overcharging refrigerant does not resolve the thermal resistance caused by the dirty coil and can introduce additional risks, including lip sucking or reduced efficiency. Proper airflow and coil cleanliness are primary contributors to optimal system performance, aligning with best auditing practices. Question 2. From a practical standpoint, is Riveros evaluating a variable air volume (VAV) system where multiple zones report inconsistent temperatures despite balanced airflow readings? Which steps should she take to accurately diagnose the issue? A. Increase the fan speed to maximum to ensure airflow reaches all zones. B. Inspect VAV terminal box actuators and controls for proper modulation. C. Add more insulation to the ductwork to prevent thermal losses. D. Replace the air handling unit filters immediately. Answer. Correct answer. D. Explanation. Filter replacement ensures airflow isn't restricted, which can directly impact VAV zone performance, while actuator inspection is important. Clogged or high-pressure drop filters often mask proper VAV operation, leading to inconsistent temperatures. Increasing fan speed without addressing restrictions can waste energy and strain equipment. Insulation may improve duct efficiency but does not correct control or airflow restriction issues. Auditing procedures emphasize methodical verification of all airflow impediments before invasive changes. Question 3. Given the circumstances, Mr. Patel is auditing a hydronic system in a commercial building and observes that the differential pressure across the pump is lower than expected. What is the most appropriate initial action? A. Immediately replace the pump motor. B. Check for closed or partially obstructed valves in the system. C. Increase system flow by opening the expansion tank. D. Add more antifreeze solution to the system. Answer. Correct answer. C. Explanation. In hydronic systems, proper flow is essential for heat transfer efficiency. If differential pressure is low, the first step is to verify that valves are correctly positioned and unobstructed to allow designed flow. Opening the expansion tank does not directly resolve flow issues, but proper fluid volume and system balance may be involved. Pump replacement is premature without identifying root causes. Adding antifreeze improves freeze protection but does not correct low pressure or flow deficiencies, emphasizing systematic diagnostics in auditing. Question 4. In light of recent developments, is Nguyen is analyzing an air source heat pump system operating below expected efficiency during winter. She notes frost accumulation on the outdoor coil. Which action should she recommend? A. Switch the system to auxiliary electric heat permanently. B. Initiate a defrost cycle and verify defrost control operation. C. Reduce the thermostat set point to decrease compressor runtime. D. Replace the refrigerant with a low pressure alternative. Answer. Correct answer. B. Explanation. Frost formation reduces heat transfer, decreasing efficiency. Proper defrost control ensures the system can operate effectively in cold conditions. Relying solely on auxiliary heat increases operating costs. Reducing thermostat set points does not resolve the frost issue and may cause discomfort. Replacing refrigerant is unnecessary and potentially unsafe. Auditing heat pump performance involves confirming all operational sequences, including defrost, to maintain designed heating efficiency. Question 5. Considering the evidence Mr. Martinez finds a walk-in cooler with higher than normal evaporator superheat readings, what is the first step he should take to accurately diagnose the system? A. Adjust the expansion device without further checks. B. Measure suction pressure and verify evaporator airflow. C. Replace the evaporator coil immediately. D. Charge additional refrigerant to the system. Answer. Correct answer. C. Explanation. Elevated superheat can indicate insufficient evaporator load or airflow restrictions. Verifying suction pressure and airflow is critical before making adjustments. Replacing the coil without confirming root cause is unnecessary. Adding refrigerant without understanding the load or airflow may lead to overcharging, system inefficiency, or damage. Auditing best practices emphasize accurate measurement and assessment of system parameters to ensure proper diagnostics before interventions. Question 6. Through careful analysis of the data, Brooks observes that a building's valve system exhibits simultaneous zone overheating and underheating. Which principle should guide her recommended solution? A. Increase ductwork insulation to balance temperatures. B. Verify and calibrate zone controllers and thermostats. C. Replace the air handling unit with larger capacity unit. D. Close bypass dampers to reduce system variability. Answer. Correct answer. B. Explanation. Proper control of individual zones is essential in valve systems. Calibration ensures accurate temperature readings and modulation. Simply increasing insulation or replacing equipment does not address the underlying control discrepancy. Closing bypass dampers may worsen imbalance if airflow distribution is not correctly regulated. Auditing requires diagnosing instrumentation and control devices first, ensuring accurate feedback and system responsiveness. Question 7. In an effort to improve indoor air quality, Lopez discovers HICO readings in multiple zones of school. Which strategy is most effective to correct this? A. Install larger fans to increase airflow. B. Adjust the ventilation system to increase outdoor air intake. C. Replace all ductwork to eliminate leaks. D. Reduce occupancy to match current airflow. Answer. Correct answer. A. Explanation. Increasing outdoor air intake directly addresses co-accumulation by improving ventilation rates. Installing larger fans without ensuring proper duct design may not resolve the issue and could increase energy usage. Replacing ductwork is costly and unnecessary unless leakage is severe. Reducing occupancy is temporary workaround and impractical. Auditors prioritize verifying ventilation effectiveness relative to occupancy and co-levels to recommend proper IAC improvements. Question 8. With respect to energy auditing, Chang finds a commercial building's HVAC system running continuously even during unoccupied hours. What principle should guide a recommendation? A. Maintain constant operation to prevent equipment cycling. B. Implement scheduling or setback controls to reduce unnecessary runtime. C. Manually shut down the system each night. D. Increase thermostat set points to reduce cooling load. Answer. Correct answer. B. Explanation. Proper energy auditing identifies opportunities for automated control strategies that align operation with occupancy. Implementing setback or scheduling controls optimizes energy use without compromising comfort. Constant operation wastes energy and increases wear. Manual shutdown is inefficient and unreliable, and adjusting set points alone does not address overall runtime. Auditors recommend evidence-based interventions targeting operational efficiency, integrating control systems effectively. Question 9. Demonstrated by Sullivan's inspection of rooftop unit, he notices that the electrical panel shows multiple tripped breakers correlated with high motor amperage. What should be his first diagnostic action? A. Replace all motors immediately. B. Measure voltage and current to identify the cause of overload. C. Reset breakers repeatedly to maintain operation. D. Increase breaker ratings to prevent future trips. Answer. Correct answer. C. Explanation. Diagnosing electrical overload begins with accurate measurement of voltage, current, and equipment load. Trip breakers indicate potential overload, short circuits, or motor inefficiency. Replacing motors or increasing breaker size without verifying root cause risk safety and equipment damage. Repeated resetting bypasses underlying problems. Auditing practices prioritize measurement, comparison with manufacturer ratings, and systematic investigation of electrical anomalies before corrective action. Question 10. To better understand system performance, Kim monitors a building's chilled water system and observes inconsistent temperature differential across the coils. What should guide her next step? A. Increase pump speed to force uniform flow. B. Balance the system using flow measuring devices and valve adjustments. C. Replace the entire coil system. D. Add more chilled water to the loop. Answer. Correct answer. D. Explanation. Balancing the system ensures proper flow distribution and temperature consistency. Using flow measuring devices and valve adjustments addresses differential inconsistencies. Increasing pump speed indiscriminately may cause overflows or energy waste. Replacing coils is unnecessary without identifying flow issues. Proper auditing focuses on measuring, adjusting, and documenting system hydraulics to optimize efficiency, reflecting fundamental principles of chilled water system diagnostics and load management. Question 11. Through the lens of recent audit data, Mr. Davis inspects a commercial building's chilled water system and observes that several valves are partially closed, resulting in uneven cooling across zones. What should he do first to improve system performance? A. Replace the valves immediately. B. Adjust and balance the valve positions using flow measurement devices. C. Increase pump speed to compensate for reduced flow. D. Add more chilled water to the loop. Answer. Correct answer. B. Explanation. Uneven cooling often results from improperly balanced valves restricting flow. Adjusting valves using calibrated flow measuring instruments ensures each zone receives proper water flow without overloading the system. Replacing valves prematurely is unnecessary if they function mechanically. Increasing pump speed may worsen imbalance and energy usage. Adding more water without balancing does not solve the underlying issue. Proper auditing prioritizes flow measurement, adjustment, and verification to achieve optimal system efficiency. Question 12. Considering the evidence, is Lopez audits at EOSTEM and notices erratic indoor unit temperatures despite normal outdoor conditions. What is the most effective initial action? A. Replace the refrigerant in all indoor units. B. Inspect communication signals between the outdoor unit and indoor controllers. C. Increase compressor speed to stabilize output. D. Install additional thermostats in each zone. Answer. Correct answer. C. Explanation. In EOSTEM, erratic indoor temperatures can result from communication issues, sensor errors, or compressor modulation problems. Checking signal integrity ensures the control commands are properly received. Increasing compressor speed indiscriminately can worsen instability if the system is miscommunicating. Adding thermostats or replacing refrigerant does not address the root cause. Auditing ERF systems requires sequential evaluation of controls, sensors, and system responsiveness before physical intervention. Question 13. In what ways can Mr. Ahmed determine the root cause of a commercial air handling unit's AHU drawing higher than normal amperage? A. Immediately replace the motor. B. Measure voltage current and inspect bearings for mechanical drag. C. Reduce the fan belt tension to lower load. D. Shut down the unit and increase duct insulation. Answer. Correct answer. D. Explanation. High amperage can result from mechanical resistance, electrical issues, or airflow restriction. Systematic measurement of voltage and current helps identify electrical overload, while inspecting bearings and belts ensures mechanical efficiency. Reducing belt tension may reduce airflow but can damage belts or reduce performance. Simply increasing duct insulation does not solve the root cause. Auditors follow a structured process to differentiate mechanical, electrical, or airflow-related causes before recommending replacement or system changes. Question 14. From a practical standpoint, Isa Patel observes frost build-up on the outdoor coil of a commercial heat pump during a winter audit. What is the correct approach to maintain efficiency? A. Switch entirely to auxiliary heat to prevent coil frost. B. Check the frost cycle operation and sensor accuracy. C. Reduce indoor thermostat set point to prevent further frost formation. D. Replace the heat pump refrigerant with a low pressure type. Answer. Correct answer. B. Explanation. Frost on outdoor coils reduces heat transfer and efficiency. Correct befrost cycle operation and accurate sensor readings ensure the system can remove frost without relying excessively on auxiliary heat. Switching to auxiliary heat increases energy consumption and cost. Adjusting thermostat set points does not prevent frost accumulation. Replacing refrigerant is unnecessary and risks system performance. Auditing best practices prioritize control verification and defrost cycle function before physical interventions. Question 15. With respect to system diagnostics, Eastern UN finds a rooftop unit with suction superheat readings consistently above design during a summer audit. Which approach should he take first? A. Charge additional refrigerant to the system. B. Verify evaporator airflow and load conditions. C. Replace the expansion device immediately. D. Increase condenser fan speed to lower head pressure. Answer. Correct answer. D. Explanation. Elevated superheat may indicate low refrigerant flow, insufficient evaporator load, or restricted airflow. Verifying evaporator airflow ensures the issue isn't caused by poor air delivery. Replacing the expansion device or adding refrigerant without measurement may lead to overcharging or system damage. Adjusting condenser fan speed alone does not address the underlying superheat problem. Auditors focus on evaluating airflow, load, and component function to identify root causes before modifying the system. Question 16. When analyzing indoor air quality, ISKIM detects unusually high particulate matter in multiple zones of a commercial office. Which intervention aligns best with auditing standards? A. Replace the entire HVAC system. B. Upgrade filtration and inspect ventilation pathways. C. Reduce occupancy to limit particle generation. D. Increase fan speed continuously. Answer. Correct answer. C. Explanation. High particulate levels indicate insufficient filtration or ventilation. Upgrading filters and inspecting ducts directly address the source and transport of particulates. Simply increasing fan speed may distribute particles rather than remove them effectively. Replacing the entire system is excessive unless it is failing mechanically. Reducing occupancy is a temporary mitigation but does not solve the systemic HVAC problem. Auditing emphasizes identifying contamination sources, improving filtration, and verifying proper ventilation delivery. Question 17. Based on the information, Mr. Sullivan notices inconsistent airflow across valve boxes in a multi-zone building. What should guide his corrective recommendation? A. Increase fan speed to force airflow. B. Inspect and calibrate valve actuators and controllers. C. Seal all duct joints to prevent leakage. D. Replace the air handling unit entirely. Answer. Correct answer. B. Explanation. Valve systems rely on precise control of dampers to regulate zone airflow. Calibration ensures accurate response to thermostat commands. Simply increasing fan speed may cause uneven distribution and energy waste. Sealing ducts is good practice but may not resolve calibration errors. Replacing the OHU is unnecessary unless it is failing. Auditing methodology emphasizes evaluating and adjusting control components first to restore proper system balance and efficiency. Question 18. In light of recent developments, Brooks observes that a chilled water system's differential pressure varies widely during simultaneous zone cooling calls. Which approach is best? A. Increase pump speed to maintain constant flow. B. Balance the system using flow meters and valve adjustments. C. Add more chilled water to the loop. D. Install secondary bypass to equalize pressure. Answer. Correct answer. A. Explanation. Variable differential pressure is often caused by unbalanced flow or improper valve modulation. Measuring flow and adjusting valves ensures each zone receives correct water volume. Adding water does not correct imbalance. Installing a bypass may create unintended flow patterns. Increasing pump speed can stabilize differential pressure if done correctly and monitored. Auditing practices recommend systematic measurement and adjustment to ensure flow consistency without introducing energy waste or hydraulic issues. Question 19. When evaluating combustion efficiency, Mr. Martinez observes a gas-fired furnace producing higher than normal co-emissions. Which auditing principle should guide the corrective action? A. Increase fuel input to raise temperature. B. Adjust the air-to-fuel ratio for optimal combustion. C. Replace the furnace immediately. D. Reduce heat exchanger surface area. Answer. Correct answer. D. Explanation. High CO levels indicate incomplete combustion. Adjusting the air-to-fuel ratio restores proper oxygen levels and combustion efficiency. Simply increasing fuel input worsens co-production. Replacing the furnace is unnecessary if operational adjustments resolve emissions. Reducing heat exchanger surface area is unsafe and inefficient. Auditing standards prioritize analyzing combustion parameters, verifying airflow, and optimizing fuel delivery to maintain safe, efficient operation in compliance with regulations. Question 20. From multiple perspectives, Rivera inspects a rooftop unit and notes frequent short cycling during mild weather. What is the most appropriate initial diagnostic step? A. Replace the compressor. B. Check thermostat deadband and control strategy. C. Increase refrigerant charge. D. Add supplemental heating to the space. Answer. Correct answer. B. Explanation. Short cycling often results from tight thermostat deadband or improper control logic. Verifying and adjusting control settings prevents unnecessary wear and improves efficiency. Replacing the compressor or adding refrigerant addresses symptoms rather than the root cause. Supplemental heating does not correct cycling behavior. Auditing emphasizes understanding control systems and proper settings to ensure reliable, energy-efficient operation while preventing mechanical stress on equipment. Question 21. While examining a commercial rooftop unit, Harris notices unusually high condenser discharge temperatures despite proper refrigerant charge. What is the most effective first action to resolve this issue? A. Replace the compressor immediately. B. Clean the condenser coil and verify airflow across the coil. C. Reduce the thermostat set point to lower system load. D. Increase refrigerant charge beyond manufacturer specifications. Answer. Correct answer. B. Explanation. High discharge temperatures often result from reduced heat transfer of the condenser due to dirt, debris, or airflow restriction. Cleaning the coil restores proper thermal exchange and reduces stress on the compressor. Replacing the compressor or overcharging refrigerant addresses symptoms, not root causes, and can cause system damage. Adjusting thermostat set points does not resolve the thermal inefficiency. Auditing best practices prioritize assessing component cleanliness, airflow, and operational parameters before any major intervention. Question 22. From a practical standpoint, O'Neill is auditing VAV's system in multi-zone office where several zones report overheating. Which steps should she take first? A. Increase the air handling unit's fan speed. B. Inspect and calibrate VAV terminal box actuators and controls. C. Add more insulation to the ductwork to prevent temperature loss. D. Reduce refrigerant charge in the cooling coils. Answer. Correct answer. C. Explanation. Overheating in VAV zones typically results from improper damper modulation, sensor miscalibration, or airflow issues. Calibration ensures that terminal boxes respond correctly to temperature commands. Increasing fan speed or altering refrigerant may not correct the underlying control issue. Adding duct insulation improves thermal efficiency but does not fix control inaccuracies. Effective auditing emphasizes verifying actuator performance, control signals, and proper airflow distribution for balanced environmental conditions. Question 23. In light of recent developments, Chen observes that a hydronic system exhibits low differential pressure across a circulating pump during an audit. What is the most appropriate first diagnostic action? A. Immediately replace the pump. B. Check for closed or partially obstructed valves and confirm system balance. C. Add more antifreeze solution to the system. D. Increase system flow by raising the expansion tank pressure. Answer. Correct answer. D. Explanation. Low differential pressure often indicates restricted flow or unbalanced valves. Initial auditing involves inspecting all valves, confirming proper positions, and verifying system hydraulics. Pump replacement is premature without confirming root causes. Adding antifreeze affects freeze protection but not hydraulic performance. Proper adjustment of system volume and pressure may improve flow and restore differential pressure. Auditing emphasizes careful measurement, evaluation, and balancing prior to mechanical replacement. Question 24. Given the circumstances, Thompson inspects an air-source heat pump during winter and notices frost accumulation on the outdoor coil. Which intervention should she prioritize? A. Replace the refrigerant with a low-pressure type. B. Initiate a defrost cycle and verify defrost control operation. C. Reduce the thermostat set point to decrease compressor runtime. D. Switch permanently to auxiliary electric heat. Answer. Correct answer. C. Explanation. Frost formation impedes heat transfer, reducing efficiency. Correct defrost cycle operation ensures proper melting of frost and maintains system performance. Reducing thermostat set point does not prevent frost and may increase discomfort. Switching to auxiliary heat permanently raises energy use unnecessarily. Replacing refrigerant is unwarranted unless system charge or type is incorrect. Auditors focus on control verification, sensor function, and operational sequences to maintain reliable heat pump performance. Question 25. Through careful analysis, Mr. Lopez observes a walk-in cooler with high evaporator superheat readings. What is the recommended first step to diagnose the problem? A. Adjust the expansion device without further checks. B. Verify suction pressure and evaporator airflow. C. Charge additional refrigerant to the system. D. Replace the evaporator coil immediately. Answer. Correct answer. B. Explanation. Elevated superheat indicates insufficient refrigerant evaporation, often caused by low airflow, improper expansion device operation, or low load. Verifying suction pressure and airflow confirms whether the evaporator is receiving adequate air and load. Adjusting the expansion device or adding refrigerant without proper measurement risks overcharging and potential damage. Replacing the coil is unnecessary unless airflow. Refrigerant issues are ruled out. Systematic evaluation is essential in advanced auditing practices. Question 26. In terms of indoor air quality, ISKIM detects elevated CO levels in multiple classrooms. Which corrective measure aligns best with auditing standards? A. Install larger fans to increase airflow. B. Reduce occupancy in the building. C. Adjust ventilation system to increase outdoor air intake. D. Replace ductwork to eliminate leaks. Answer. Correct answer. C. Explanation. High CO indicates insufficient ventilation relative to occupancy. Increasing outdoor air intake addresses the root cause by improving fresh air supply to zones. Installing larger fans alone does not ensure proper airflow distribution. Reducing occupancy temporarily mitigates symptoms but does not resolve the system deficiency. Replacing ducts is unnecessary unless there is evidence of significant leakage. Auditors prioritize verifying ventilation effectiveness and adjusting control strategies before invasive modifications. Question 27. With respect to energy auditing, Mr. Sullivan finds that a commercial HVAC system operates continuously during unoccupied periods. Which action is most aligned with energy efficiency practices? A. Increase thermostat set points to reduce cooling load. B. Implement scheduling or setback controls to reduce runtime. C. Maintain constant operation to prevent equipment cycling. D. Manually shut down the system each night. Answer. Correct answer. A. Explanation. Continuous operation wastes energy and increases wear. Scheduling or setback controls automatically align system runtime with occupancy, optimizing energy use. Manual shutdown is inefficient and prone to human error. Maintaining constant operation prevents unnecessary cycling but does not reduce energy consumption. Adjusting set points alone reduces load slightly but is insufficient without proper scheduling. Auditing emphasizes integrating control strategies with evidence-based operational adjustments. Question 20. During a rooftop unit inspection, Brooks notices tripped breakers and high motor amperage. What is the first step in diagnosing this electrical issue? A. Increase breaker ratings to prevent future trips. B. Reset breakers repeatedly to maintain operation. C. Replace all motors immediately. D. Measure voltage and current to identify the cause of overload. Answer. Correct answer. B. Explanation. Trip breakers indicate overload, short circuit, or mechanical resistance. Measuring voltage and current helps identify the source of electrical stress. Repeatedly resetting without proper diagnosis risks equipment damage and safety hazards. Increasing breaker ratings bypasses protection and can create dangerous conditions. Motor replacement is premature without verifying the underlying issue. Systematic auditing identifying root causes through measurement and evaluation before corrective action. Question 29. As demonstrated by Mr. Patel's audit of chilled water system, inconsistent coil temperature differentials were observed. Which approach ensures optimal system operation? A. Increase pump speed to force uniform flow. B. Balance the system using flow meters and valve adjustments. C. Add more chilled water to the loop. D. Replace the coil system entirely. Answer. Correct answer. C. Explanation. Inconsistent temperature differentials often result from improper hydraulic balance or core flow restrictions. Balancing using flow meters and adjusting valves ensures proper flow distribution. Increasing pump speed without measuring flow can cause overpressurization and inefficiency. Adding water may be necessary to maintain adequate system volume, but proper balancing is essential. Replacing the coil is excessive unless the system is physically compromised. Auditing principles emphasize measurement, calibration, and controlled adjustment to restore performance. Question 30. From multiple perspectives, is Rivera observes frequent short cycling of a rooftop unit during mild weather. What is the most appropriate initial action? A. Replace the compressor. B. Check thermostat deadband and control logic. C. Increase refrigerant charge. D. Add supplemental heating to the space. Answer. Correct answer. D. Explanation. Short cycling typically arises from narrow thermostat deadband, improper control logic, or oversized equipment relative to load. Evaluating and adjusting control settings restores stable operation and prevents excessive wear. Replacing the compressor or adding refrigerant addresses symptoms but not root cause. Supplemental heating does not resolve short cycling and can increase energy use. Auditing focuses on control verification, sequencing, and operational logic before any physical or refrigerant modifications.